guys think Shakira fell, but Ali don't? I can explain about that. Most casual slippers are made of cheap, low-density polymer or soft rubber like EVA. When you drag or slide your foot on a surface, the friction instantly generates heat. Because slippers have low specific heat capacity, their temperature spikes quickly. This heat causes the material to undergo thermal softening. So now, I'll explain about rotational mechanics and thermal physics. We are meeting the need for dual-purpose, adaptable footwear that solve two major physics problems simultaneously. This prevents severe joint injuries caused by excessive rotational locking in shoes and stopping dangerous slip caused by thermal material softening in everyday slippers. Next, I can give example from athletes and also general public. For athletes, we have pro athletes playing at court sport who suffer from high joint torque. Meanwhile, everyday consumer and also elderly individual like resident at home, nursing home or housewife at home who frequently needs to use casual rubber slippers on sleek kitchen or outdoor tile surface. And guys, we have problems. This problem is experienced daily. Athletes face it during every high-intensive training session or competitive match when executing sudden fast 180 degrees pivot. Meanwhile, slippers users experience it multiple times a day, specifically when walking on hot outdoor concrete, freshly mopped indoors, and also greasy kitchen surface where sliding friction is high.
Hello guys, have you ever wondering why wearing shoes is suitable for sport? So today I will explain this issue related to physics. So let's find out. So I want to explain why wearing a shoes can prevent risk of falling compared to wearing a slipper. So we are going to use the concept of rotational mechanic and thermal physics. First, let's talk about rotational mechanic. So when we move, especially during activity like passing the ball, our ankle experience force that can cause twisting or rotation. This force create torque, which our ankle must control to keep us balanced. So slipper usually lack proper ankle support. Because of this, when I twist my foot suddenly, the slipper does not stabilize my ankle. This allows the foot to rotate excessively, which can lead to my ankle twisting or injured. Like what happened when I split my ankle chasing the ball from my friends. So on the other hand, shoes are designed to provide firm support around the ankle. The structure of shoes limit excessive rotation by distributing the force more evenly. This helps protect the ankle from sudden twist and reduce the risk of falling or injured during quick movement. So when we look at the rule of thermal physics, when we move, our feet generate heat and sweat. Slipper often use material that do not manage heat. So this causes a sweat to ball out inside the slipper, making the foot slippery and reducing friction between the foot and the slipper surface. So this means that my foot can slip inside the slipper during movement, make it hard to keep stable. This slipping inside the slipper increase the chance for me to losing balance and falling. In contrast, shoes often use breathable material that allow heat to escape. This help keep the foot dry and maintain good friction between the foot and the shoes. As a result, shoes provide a better grip and greater comfort while moving, which help maintain stability and prevent fall. So to summarize this concept, we know that slipper can increase the risk of falling due to the lack of support that explained by rotational mechanic and core head. So we know that shoes have stronger support and better material design that help protect the ankle and maintain grip.
Hi! Before I start my presentation, have you ever seen a basketball player do a spin move? If not, let me show you some videos of them do the spin move. In basketball, a split-second spin move can mean the difference between an open layup and a turnover. But behind that flash of skill is a masterclass in rotational mechanics. Let's break down exactly how a sports shoe handles this instant maneuver using physics. To initiate the spin without slipping, the shoe relies on rotational friction to generate torque. The torque required to whip the player around is governed by the equation. Once the turn begins, the player utilizes the conservation of angular momentum, defined as by pulling their arms and opposite leg tightly toward the body's axis, they drastically reduce the moment of inertia. Because the player is leaning at a sharp angle during this rotation, the shoe must withstand a massive outward centripetal force. The shoe structural walls must apply an equal and opposite counterforce to keep the player sliding right off balance. We observe three critical real-life outcomes, which is high speed agility. The athlete successfully completes the 180 rotation in a fraction of a second due to maximized angular acceleration facilitated by the high traction pivot zone and lightweight shoe construction. Second, ankle and knee joint protection. Because the circular thread pattern allows the shoe to rotate smoothly on the court surface, it prevents torque spikes. The torque is smoothly transferred rather than abruptly jamming, which protects the player's ACL and ankle from rotational stress injuries. Third, controlled traction. The high coefficient of static friction between the rubber sole and the hardwood ensures that the pivot point remains fixed on the floor, preventing any power loss or dangerous sliding during the turn. So, if you see a flawless spin move, remember it's not just a talent, it is also a torque, inertia, and a physics under your feet. That's all from me. Bye!